Hari Om students, I hope all of you are staying safe at home. You maintain 2 meter distance away in public place. Always you remember it. Then what is today saying? In sacrifice, through sacrifice, with sacrifice, discover a new energy to serve others. അതായത് നമുക്ക് മറ്റുള്ളവരെ സേവനം ചെയ്യാനുള്ള ഏറ്റവും എളുപ്പമായ മാർഗം എന്താണ്? ത്യാഗം ചെയ്യുന്നതിലൂടെ നമുക്ക് മറ്റുള്ളവർക്ക് സേവനം ചെയ്യാനുള്ള ഒരു ഊർജം നമുക്ക് കിട്ടുമെന്നാണ് സ്വാമിജി നമ്മളോട് പറഞ്ഞിരിക്കുന്നത്. സോ ഇൻ സാക്രിഫൈസ്, ത്രൂ സാക്രിഫൈസ് ആൻഡ് വിത്ത് സാക്രിഫൈസ് ഡിസ്കവർ എ ന്യൂ എനർജി ടു സെർവ് അതേഴ്സ്. മറ്റുള്ളവർക്ക് സേവനം ചെയ്യാനുള്ള ഒരു ഊർജം നമുക്ക് ത്യാഗം ചെയ്യുന്നതിലൂടെ നമുക്ക് കിട്ടുമെന്നാണ് സ്വാമിജി നമ്മളോട് പറഞ്ഞിരിക്കുന്നത്. ഓക്കെ, then today we can study a new lesson, areas related to circles. In 9th standard, you already studied what is a sector, segment, etc. What do you mean by a sector of a circle? We can recall what is a sector of a circle. The sector means the portion of the circular region enclosed by two radii and the corresponding arc is called the sector of a circle. Then what is the sector of a circle? The portion of the circular region enclosed by two radii and the corresponding arc. Then this figure, two radii and the arc is here. The corresponding arc is called the sector of a. Then OAB, this is a sector of a circle. So what is the sector? The portion of the circular region enclosed by two radii and the corresponding arc is called a sector of a circle. Two radii, the corresponding arc. AB is the arc and OA and OB are the radii. Then this portion is called the sector of a circle. This shaded region is the minor sector. We can say it as minor sector, and the other unshaded region is called the major sector. This is also a sector. That is part of a circle. The portion of the circle. This is also two radii and the corresponding arc. This is the bigger sector and this is the smaller. This is minor and this is major sector. So we can write it as major sector. Major sector. So what is a sector? A sector, the portion of the circular region enclosed by two radii and the corresponding arc. Two radii and the corresponding arc is called sector of a circle. And this shaded portion is the minor sector and the bigger portion is the major sector of the circle. Both are sectors. This is the minor sector and this is the major sector. Okay. Then what is the segment of a circle? Segment means the portion of a circular region enclosed between a chord and the corresponding arc is called the segment of the circle. That is the portion of the circular region enclosed between a chord. This is a chord. AB is a chord and this is an arc. Then ADB. Therefore, the portion of a circular region enclosed by between a chord and the corresponding arc. This is the chord and the corresponding arc is this. Then this portion is called the segment of a circle. This is the minor segment and this is the major segment. So this is called a minor segment. This is minor segment. Minor segment. And this portion is called a major segment. Major segment. So what is the difference between a sector and a segment? Sector means the portion of the circular region enclosed by two radii and the corresponding arc. Then segment means the portion of a circular region enclosed between a chord and the corresponding. That is the difference between a sector and a segment. Sector means the portion including two radii and the corresponding arc, and segment means the portion of a circular region enclosed between a chord and the corresponding arc is called a segment of the circle. You remember it, okay? So what is a sector? The difference between sector and a segment. The portion of the circular region enclosed by two radii and the corresponding arc is called the sector of a circle. Two radii, this portion This is the shaded portion is the minor sector and the other portion is the major sector. Two radii and the corresponding arc. Okay. Then segment means the portion of a circular region enclosed between a chord and the corresponding arc. This is the chord and the corresponding arc. So this shaded portion is called the minor segment and the other is called the major segment of the circle. Okay. Next, formula to find the area of the sector of a circle. To find the area of the sector of a circle with the angle theta. Here sector angle means this angle is theta. If you are asked to find the area of this minor sector, then what is the formula? It is equal to theta by 360 into pi r square, where r is the radius of the circle and theta is the angle of the sector. So to find the area of this sector, we use the formula. Here the sector angle is theta. So it is equal to theta by 360 into pi r square, where r is the radius of the circle and theta is the angle of the sector. This is the area of the minor sector. Then what is the area of the major sector? Area of the major sector is equal to area of the circle minus area of the minor sector. If we find the area of the circle minus area of the minor sector is equal to area of the major sector. So to find the area of the minor sector, the formula is theta by 360 into pi r square, where r is the radius of the circle and theta is the angle of the sector. Then to find the length of an arc of a sector, we are asked to find this arc. To find the length of the arc of this sector of angle theta, then we use the formula theta by 360 into 2 pi r. So you look here, area, we know that the area of the circle is pi r square. So to find the area of the sector, we use the formula theta by 360 into the formula for area of circle pi r square. Then we know the circumference of a circle is 2 pi r. Then to find the length of an arc of a circle, we use theta by 360 into 2 pi r. Remember it. To find the area of the sector, we use theta by 360 into pi r square, because the area of the circle is pi r square. Then to find the length of an arc of a sector of a circle, we use the formula theta by 360 into 2 pi r, because the circumference of the circle is 2 pi r. You remember it, the difference. Therefore, area of the sector of a circle is equal to theta by 360 into pi r square, where r is the radius of the circle and theta is the angle of the sector. Then length of an arc of a sector of angle theta is equal to theta by 360 into 2 pi r. Okay. Next is how to find the area of the segment of a circle is equal to, here what is the segment here? Badiri, what is the portion of segment? This is this portion OAPB is a sector and this is a triangle. The space between this sector and the triangle is the segment. This portion is the segment of the circle. That is here OAPB is a sector and OAB is a triangle. Therefore, how will you find the area of the segment? This portion is the segment. Then to find the area of the segment, what we do? Area of the segment of a circle is equal to area of this sector. If the area of the sector is OAPB, the whole portion, minus area of the triangle. If we subtract from the area of the sector minus area of the triangle, then we will get the area of the segment. This portion is the segment. This is a chord and this is the arc. The part including the chord and the circular region arc is called the segment of a circle. Then this portion is a sector of the circle, because the two radii and the corresponding arc. OAPB is a sector of the circle. So to find the area of this shaded region, that is the segment, we use the formula area of the sector minus area of this. If we subtract the area of the triangle, then we will get the shaded region. Therefore, what is the area of the segment? Area of the segment is equal to area of the sector OAPB minus area of this triangle OAB. If we subtract this area of the triangle from this sector, we will get this shaded region's area. That shaded region is the segment of the circle. Okay. Therefore, area of the segment of a circle is equal to area of sector OAPB minus area of triangle OAB. What is the formula to find the area of the sector of angle theta? It is equal to theta by 360 into pi r square minus area of triangle AOB. So to find the area of the segment of a circle with the sector angle theta, we use the formula area of the sector minus area of that corresponding triangle. Therefore, it is equal to area of sector OAPB minus area of triangle OAB. That is equal to theta by 360 into pi r square minus area of triangle AOB. Remember the formula. Theta by 360 into pi r square minus area of triangle AOB. That is area of the sector OAPB minus area of triangle OAB. The shaded region is the segment. So, if we subtract the area of the sector minus area of this triangle, you will get the area of the shaded region. Okay. Next question. Find the area of sector of a circle of radius 21 centimeter and angle of the sector is 60 degree. So here radius is equal to 21 centimeter and sector angle is theta is equal to 60 degree. Then what is the formula to find the area of the sector? Area of the sector is equal to Arman theta by 360 into pi r square. Then here what is the angle of the sector is 60 degrees. So it is equal to, instead of theta we write 60 by 360 into pi we can write as 22 by 7 into r square. What is r here? 21. So it is equal to 21 into 21. Here we can cancel this 6. Then we can divide it 7. We can divide by 21 by 7 is 3. 21. Then 6 also we can divide by 2. Here 11. That is 11 into 3 into 21. 11 into 3 is 33. What is 33 into 21? 693 divided by 3. 3 2s are 6. 3 3s are 9. Then 3 1 10. 3 3. Then what is our answer? Therefore it is equal to 231. That is equal to 231. Then what is the unit? Area of the centimeter square. Centimeter square. So the area of the sector of a circle of radius 21 centimeter is equal to, first we here the radius is 21 and the sector angle is theta is equal to 60 degree. Therefore, area of the sector is equal to theta by 360 into pi r square. That is 60 by 360 into, instead of pi we write 22 by 7 into 21 into 21. Then it is equal to 231 centimeter square. So the area of the sector of sector angle 60 degree and radius 21 centimeter is equal to 231 centimeter square. So it is equal to 231 centimeter square. Okay. Next question. A cow is tied with a rope of length 14 meter at the corner of a rectangular field of dimensions 20 meter into 16 meter. This means that what is the length of this rectangular plot? 20 meter into 16 meter means length is 20 meter and breadth is 16 meter. So here this is 20 meter and the breadth is 16 meter of a rectangular field. Find the area of the field in which the horse can graze. A cow is tied with a rope with a 40 meter at the corner of a rectangular field. We can take this point as the cow is tied here. Then the length of the rope is 14 meter. 14, this is equal to 14 meter. Length of the rope is this 14 meter. Then what is the area the horse can graze? The horse can graze is equal to, from this the horse can graze up to this. Here is 14 and here is 14. Then what is the shape of this figure? Can you say? What is the Uttara? This shape is the form of a sector. So what is the area of the field the horse can graze is equal to area of this sector. Area of this sector, we can name it as AEPD. So the area of the field in which the horse can graze is equal to area of this, that is the shaded region. Okay, the shaded region is the shape of a sector. So to find the cow is not horse, the cow. A cow is tied with a rope of length 14 meter at the corner of a rectangular field. Then the dimensions is 20 meter to 60 meter. Find the area of the field in which, not horse, cow, in which the cow can graze. The area of the field in which the cow can graze. Then the cow is tied here and the length of the rope is 14 meter. That means that the cow can graze from here to here. This portion only this cow can graze because the length of the rope is 14 meter. If it is 16 meter, can graze up to here. But the length of the rope is 14 meter and it is tied here. So it can graze the field from this portion to this portion. That is the form of a sector. Then what is the area of the field in which the cow can graze is equal to area of the sector DEPD. Okay. Therefore, the area of the field in which the cow can graze is equal to this portion up to this portion. This is the, because the length of the rope is 14 meters, is equal to the area of the sector, area of the sector DEPD. This we can write as EF. DEPF. Then what is the radius of the sector? The length of the rope is the radius of the sector. And what is the sector angle? This is a rectangular field. So what is the sector angle here? Sudarshan, can you say? This is a rectangular field. So this angle is 90 degrees. So the sector angle is 90 degree and the radius is equal to the length of the rope, that is 14 meter. Therefore, the area of the field in which can graze is equal to the area of the sector DEPF, that is equal to theta by 360 into pi r square. Here what is theta? Theta is equal to 90 degree. 90 by 360 into 22 by 7 into what is the radius? 14 square. That is 14 into 14. Here 4, 7 2s are 14. That is 22 into 14. Here also we can cancel this 7. 2 and 2 cancel. Then it is equal to 14 into 11. 14 into 11. That is equal to 154. 154. That is equal to 154. What is the unit? Meter square. So what is the area of the field in which the horse can graze? It is equal to area of the sector. Here it is a rectangular field. So the sector angle is, this angle is 90 degree and the radius of the sector is equal to the length of the rope, because the cow is tied to this point and the length of the rope is 14 meters. So up to this area the cow can graze. So the area of the field the cow can graze is equal to area of this sector DEPF, that is equal to theta by 360 into pi r square, that is 90 by 360 into 22 by 7, radius is 14 meter. Then we got the answer as, then what is the area of the field in which the cow can graze is equal to 154 meter square. Okay. Therefore, to find the area of a sector, we use the formula area of the sector is equal to theta by 360 into pi r square. And the area of the length of the arc of a sector is equal to theta by 360 into 2 pi r. Then to find the area of a segment, we use the formula area of the sector minus area of the corresponding triangle, or theta by 360 into pi r square minus area of the triangle. You remember all the formulae. Okay. We can do more questions in the next class. Assignments will be given through Google Classroom. Thank you and Hari Om.